Alright folks, welcome back. I had a request to come in for the following problem, so let's look at it. There's actually two problems here. I may do one, I may do both, I don't know, we'll see. The first question was asked is, what is the empirical formula of the following? There's two of them. Vanadium oxide is 50% vanadium and 44% oxygen. That's the first problem. Second problem is a compound. Notice they don't even tell us the name of it or anything. A compound contains 10.52 grams of nickel and 4.3 grams of carbon and 5.10 grams of nitrogen. Now, I've done several problems to these, but this problem was asked specifically by an individual, so I figured I'd give it a shot for them. So, here's the video. Let's start with number one. On number one, first thing that we need to do is just line up our data, get it in order. What I choose to do is just basically think of, well, I've got vanadium here, so I'll put a letter V here, and I've got oxygen, so I'll put O over here. Because to me, working these empirical formulas are a lot easier to work them vertically. Okay. Sorry, I use a mouse, so I'm not the best at drawing left to right. I need to spend some money and get a nice digital pen. But anyway, notice they're telling us the percent compositions, and that's kind of nice. All that you have to do is when they tell you the percent composition, for example 56.0%, all that we have to do is just basically drop off the percent sign and change it to grams. So we're just going to pretend that percentage is grams, because what you're doing is you're pretending that your sample is out of a 100 gram sample instead of 100%. So this is basically 56.0 grams, and this is grams of vanadium. Okay, and over here you're doing the same with the thing for the oxygen. You're going to pretend that it's 44.0 grams of oxygen. Now, the next thing that we need to do is look at the molar masses of each of these. Okay, on the periodic table, which I have right here, you can see that vanadium is 50.94. Whoops, I got a new email message. So that's 50.94. Okay, now on oxygen, if you look on this periodic table that I'm using, oxygen is exactly 16. So let's go ahead and get that. So we'll put 16 here. Now, so basically what we're doing is we're converting our number of grams into the number of moles. But to me, these are just so much easier to just stack them and work them like this. Okay, now we need a calculator, so I'll get my TI-83 here, and I'll punch in 56.0 divided by 50.94. Now I want to keep 3 sig figs because that's what I have up here on top is 3. So my answer here is basically 1.099, which technically is 4 sig figs. So I could use that, or I could just go ahead and round it to 10 to give me 3 sig figs. But anyway, that would be my moles of vanadium. Okay, you do the same thing over here with oxygen. Whoops, that's not my calculator. You will take the 44.0 and divide it by 16, and when you do that, you get 2.75. So this is 2.75, and that's moles of oxygen. Now, once you get down to moles here, what you want to do is you want to divide by the smallest amount. The smallest amount of moles here is the 1.10. Okay, so we'll divide by 1.10. And what you're doing is you're basically forcing it to be exactly 1. Okay, so divide by the smallest amount, and what that does here is that gives you 1 vanadium. Now over here, I don't know what that gives you. Let's see what we get on our calculator. That gives us 2.75 divided by 1.10. 2.10. Okay, that gives us the number 2.5. So this is 2.5, and that's 2.5 ohs. Now, in the earlier videos, I told you that if you get a half, you should just go ahead and multiply everything that you see here by 2, because as this as a fraction is 5 halves. 2.5 is. So basically, if you want to clear your fractions, because remember, we cannot write decimals or fractions as subscripts in chemistry. In other words, we couldn't write this V10 2.5. That's just wrong. So what we're going to do is we're going to multiply by 2 to clear our fractions. So that way, that gives us 2 vanadiums, and that gives us 5, because 2 times 2.5 is 5. That gives us 5 oxygens. So our final empirical formula for this then will yield, basically, I shouldn't say yield, but will give us V2O5. Okay, and this is our empirical formula. So anyway, I'm going to go ahead and I'm going to check this email, and I'll do the second problem in another video. So watch this one, and if you want to, watch the following video, and it'll be helpful. Okay? Alright. Hope it was helpful.